Hello, welcome to the FRQ of the day. Today we're going to try the 2009 Form B number 4. Which I think this is the sort of thing that could very well be asked of you in this year's exam. And it's Cinco de Mayo. There's my Cinco de Mayo tie that I always wear on Cinco de Mayo. So happy Cinco de Mayo. Anyway, so let's read this problem. So this problem says a manufacturer of toxic pesticide granules plans to use a dye to color the pesticide so that birds will avoid eating it. A series of experiments will be designed to find colors or patterns that 3 bird species, blackbirds, starlings, and geese, will avoid eating. Representative samples of birds will be captured to use in the experiments, and the response variable will be the amount of time a hungry bird will avoid eating food of a particular color or pattern. Part A. Previous research has shown that male birds do not avoid solid patterns. However, it is possible that males might avoid patterns colors displayed in a pattern, such as stripes. In an effort to prevent males from eating the pesticide, the following 2 treatments are applied to the pesticide granules. Treatment 1, a red background with narrow blue stripes. Treatment 2, a blue background with narrow red stripes. To increase the power of detecting a difference in 2 treatments in the analysis of the experiment, the researcher decided to block on the 3 species of birds, blackbirds, starlings, and geese, and assuming there are 100 birds of each of the 3 species, explain how you would assign birds to treatments in such a block design. And then part B, other than blocking, what could the researcher do to increase the power of detecting a difference in the 2 treatments in the analysis of the experiment? Explain how your approach would increase the power. So if you want to pause the video and give that a shot, that would be great. All right, so now, so first of all, it's asking us how would we assign these 100 birds. And of course, we want to assign them randomly to the 2 treatments within each block. Blocking means you divide them up into groups and do a full experiment within each block. So within each block, you're going to randomly assign to treatments, and then into treatment groups, treat those groups exactly the same, and then you would explain, if you were selling the full experiment, you would explain how you're comparing the results between the groups. But in this case, it just says how you're going to assign, and the key thing is randomly. So what you had to do is, there's different ways you could say this, but you had to clearly state how you would randomly assign within one of the blocks, and then say that you do similar things in the other blocks. And so this is what I would say. And so this is how you would say that you're going to randomly assign. So if I start with the blackbirds, assign each of the 100 blackbirds a unique integer from 1 to 100. It's important that you say unique, okay, or distinct, or ignoring repeats. All right. Use a random number generator to create 50 unique integers from 1 to 100. You have to say it like that. Okay, you know, we're picking out 50 to go in treatment 1, 50 to go in treatment 2. You have to say unique or distinct, and you have to say from 1 to 100. All right, like that. All right, the 50 blackbirds with the 50 integers receive treatment 1. So you have to. It's not the numbers that go in the treatment; it's the birds, the blackbirds. So you have to say that. All right, the other 50 blackbirds receive treatment 2. Okay, so there I've clearly stated how I'm randomly assigning the blackbirds. In a similar fashion, randomly assign the 100 starlings into 2 groups for treatment 1 and treatment 2, and randomly assign the 100 geese into 2 groups for treatment 1 and treatment 2. But what you had to do is you had to clearly state how you're going to randomly assign one of the groups of birds, and say you're doing the same thing for the other groups, and that would give you an E for that one. And so then the next one says, what can we do to increase power? Now, by the way, so yes, whenever you to increase power, or to increase, in essence, accuracy and lessen variability, is, proper blocking will do that. But if it was, by the way, if it was in a sampling situation, then properly stratifying would do that. And that's the same sort of thing. You're creating homogeneous groups, okay? And that could certainly be asked of you. You know, what could you do to decrease variability or increase accuracy? That is proper stratifying and sampling, or proper blocking experiments. And blocking and stratifying are the same thing, except that blocking occurs in an experiment. In other words, blocking occurs when a treatment has been randomly assigned. Okay, and that's certainly what's going on here. So what else could you do to increase power? Well, there's 2 things. Increasing sample size, which is the main thing, or you could change your alpha. All right, and so this is and you had to explain it. And so to explain it, you had to say, well, first of all, you had to say increase sample size. Then you had to, there's different ways you can explain it, but you could say by increasing the sample size, it's decreasing the variability in my results, in my sampling distribution or in my results. And it'd be good to mention the results since it's mentioned it up here. All right, it mentioned that the response is going to be, and where did it say it? The response is going to be the time that they avoid eating. So, and where did it say it? It says, and the response variable would be the amount of time a hungry bird will avoid eating food. So let me show you what I said in regards to that. And so I said I would increase the number of birds in the experiment. All right, and by the way, increasing sample size here, well, you could have said that, I guess, but main is increase the number of birds. Increasing the number of birds, increasing the number of birds will reduce, increasing the number of birds will reduce the variability in the results. If there is a difference in the true amount of time that a bird would avoid eating food with treatment 1 or treatment 2, increasing the number of birds will make the experimental data closer to the true values and make detecting this true difference more likely. Like I said, you had to state that you increase the sample size, and that will result, in essence, in more precise results. And so there you go. So that's that. Or like I said, you could have said that you could have increased alpha, and you could have said something about that. But this was the main thing. So thanks for watching the video. If you have any questions, please send them to me. And I hope you have a very nice Cinco de Mayo, and look forward to seeing y'all again soon.